Today we are looking at lesson 63, and we will learn how to add two vectors together. We might be given the vectors in polar form, and then we want to find out, well, if we did one vector and then we did the other vector, where would we end up? Or we might be given both vectors, like the red one, which would be a negative positive, so that would be a second quadrant vector, plus, and then my blue one, positive negative, that would be a fourth quadrant vector. And what happens if we add those together? So let's talk about the steps, and then we will go through a couple of examples together. First step is always that I would like for you to draw each of those two vectors separately. So we're going to start off, if we have a problem like 30 at 55 degrees plus 10 at 170 degrees, we're just going to start by drawing two diagrams as we have already learned how to do. 55 degrees is first quadrant, a little bit more than 45 degrees, so maybe something about like that. And we're going to label that it is 30 long, and we're going to label that our angle is 55 degrees. Now for the 10 at 170 degrees, first thing I'm going to notice is my first vector was 30 long. This one is only 10 long, so it's going to be a lot shorter. It's going to be about a third as long as the first one. This one is almost to 180 degrees. It is in the second quadrant, and that looks about a third as long as what I had before. So this angle is 170 degrees, which means my little angle inside there is only 10 degrees. And I need to label that that one is 10 long. So I've done the first step. I have drawn each one of those separately. So I have my two diagrams there. My next step is I want to add the ihat and jhat components. We cannot add in polar form. If we are given vectors in polar form, like in this example, we must convert to rectangular. So we're going to add the ihat and the jhat components together, and we're going to take a look at that and see, where do we end up? What quadrant do we end up in? So back to my example now. I need to get ihat and jhat for each of these, and today I'm actually going to give you a little bit of a shortcut that you may start using on these. We know that ihat is the horizontal part, and jhat is the vertical part on these. So for my red one, my 30 at 55 degrees, I am in the first quadrant, so positive, positive, and we want to write that down by our picture so we know what we're doing. So to get my ihat, I am going to say that the cosine of 55 degrees is the adjacent over the hypotenuse. So my ihat is 30 cosine 55 degrees. For my jhat, I am going to take the sine of 55 degrees, and it will be jhat opposite over hypotenuse. So my jhat will be 30 times the sine of 55 degrees. So I'm going to need, by that second step, I am going to need to add the ihat for this one to the ihat for my second vector. And then I'll need to add my jhat to the jhat that I get from my second vector. So I need this and I need this. Let's get the ihat and jhat for the second vector. This time we're in quadrant 2, so we know that has to be a negative positive. So I am going to say, here's my ihat, here's my jhat. I'm going to say that the cosine of 10 degrees needs to be adjacent I hat over the hypotenuse 10. So this I hat needs to be 10 cosine 10 degrees, sort of. And I'm going to say that my sine of 10 degrees needs to be my opposite over hypotenuse, j hat over 10. So j hat needs to be 10 sine 10. The reason that I said sort of, unless we're in the first quadrant, at least one of these needs to be negative. And we just made a note that this I hat needs to be negative and the j hat needs to be positive. So I need to put this minus sign in front of my I hat. Now my second step said that I need to add my I hats and I need to add my j hats together. So what I am going to do to add these vectors, I am going to say my first I hat is 30 cosine 55 degrees, and my second I hat is negative 10 cosine 10 degrees. And those are my I hats. And then for my j hats, I am going to take my 30 sine 55 degrees, and then my other one for my green vector is positive 10 sine 10. And that is my j hat. So I will put those two together in order to get my final answer on this. Now my shortcut. Notice that the I hats are always magnitude, or that R, times the cosine of my reference angle. And my j hats are always my magnitude, my R, how long is it, times the sine of my angles. So you may start just doing R cosine the first reference angle, plus or minus for the second one, that R times the cosine of that angle. And remember, these two places were positive because my red vector is in the first quadrant and everything there is positive, positive. And for my green ones, it was Q2, which meant negative, positive. So negative for the I hat and positive for the j hat. Now we need to punch this into our calculators. So we're going to type all at once this whole line, 30 cosine 55 degrees minus 10 cosine 10 degrees. So let's go to the calculator and do that. And we can be either in a document or we can be just in our scratch pad, some kind of calculator page. Type in 30 cosine, so trig, and then we go over so that we get to cosine and push enter, and then the 55, and I'm double checking, my calculator does say DEG in the top right corner, so I know I have degrees. Now here's the trick. You've got to go outside the parentheses before you do the next part. So right arrow, and then minus 10 cosine of 10 degrees. Oops, and cosine, and then put the 10 degrees in there. Double check and make sure that only the angles are in those parentheses. If I had done the 30 cosine in my parentheses, was 55 minus 10 cosine another parentheses 10, and then close both the parentheses, my calculator would be very, very confused as to what kind of an angle I wanted to take that first cosine of. So we enter both of those at once, and that is what our I hat is going to be. Now, not so much today, but some future problems, we're going to want to make sure that we remember that with all of the places, not just rounded. So I'm also going to store it, which is up above the VAR button. So the 9, and then the button up above that is VAR, but since I want the small print above it, it is Control, and then I push the VAR button, and then I tell it what letter to store this as. Since that's ihat, I'm just going to say store it as I, and then push Enter. And now the calculator is going to remember that ihat is positive 7.359. I am going to go back to my problem and write that down before I have a chance to forget it. That when I added these, I got positive 7.359 for my ihat. Now I need to do the jhat. So now I'm going to enter 30 sine 55 plus 10 sine 10, and let that give me the jhat part. So back to my calculator now. So we just said this time it is 30 trig for sine 55. And let's suppose I forgot to go outside the parentheses. Let's see what that's going to look like. If I try to then do plus 10 sine 10 degrees, that's not what I meant. I look at what I wrote, that's not going to work. That's not what I'm trying to find. So I need to backspace, so my delete button, and get rid of those things that shouldn't have been in there, and then do my space to the right to get out of it. Now I try again to do the plus 10 trig sine of 10, and enter. And now I have 26.311, but I may want the calculator to remember it, so I'm going to do Control and then the VAR button so it stores it. And this time I want it to be jhat, so I'll have it store it as J, and push Enter again. So 26.311, and it is also positive. So I go back to my problem, and I write that down, that I have plus 26.311 jhat. Now you must write this all together with the ihat and the jhat in there, and either a plus or a minus sign in between, not a comma. A plus sign, since my calculator just said this one was positive. So let's take a look at what we have. This says I have a positive ihat and a positive jhat, which means I end up in Q1 for my final answer. So taking a look back at the pictures that we started with, a vector means you go in one direction a certain distance. So my first vector there says I go in that direction in the first quadrant, 55 degrees. I go 30 units up that way. And then from that spot where I stopped, now I turn, and from there I go in the second quadrant direction, where I would be going if I was at 170 degrees. And so I'm going this direction, and about a third is far. My final answer says, where do I end up? If I had started at the origin, and now I end up at the end of this green vector after I've done one vector, then the other one, I end up right here. And that does look like I end up in the first quadrant. So this would be my answer for this problem when I have added them. Now let me go back to my steps and make sure we have everything in there that we want just for our notes. We've added them, we've thought about what quadrant do we end up in, and then we draw that vector diagram that has all three of those vectors in there. We draw them end to end, and then we draw the final vector from the origin to the end of the second one. So let's try another example just to help this make a little bit more sense to us and get a little bit more practice in. Okay, so Tracker left the cabin and traveled 25 miles on a heading of 20 degrees. So 20 degrees, that's first quadrant. It's not very high up there. And so let's say that's about 25 miles, and here's my 20 degrees, so I've labeled that on here. That means this vector needs to be positive, positive. And with our shortcut, we know we can do r cosine of rho and then a plus or minus r of the sine for the I hat and j hat respectively. So what I am going to do for this vector is I am going to say that it is 25 cosine 20 degrees, and I made that positive. My sine is also going to be positive, 25 sine of 20 degrees. The cosine one is going to be my I hat, and the sine one is going to be my j hat. And you'll see in a moment why I left that space in there. Now I'm going to draw my second vector. So this time we're going at 215 degrees. So that's going to be third quadrant. That's going to be 35 degrees past the 180. So that's going to be about like that. Except I probably want to make that longer. Should be about twice as long as the 25. So I'm going to let that be 50. And this whole angle was my 215. My reference angle is 35 degrees. If it is not in first quadrant, I want the obtuse angle, or the one that's even more than 180 degrees, and I want the reference angle on there. This quadrant is going to be negative, negative. So my I hat and j hat parts will both be negative. So I'm going to do a minus and a minus. For this one, the length is 50. The I hat, I'm going to use cosine 35 degrees, and the j hat, I'm going to use sine of 35 degrees. You must draw the pictures. You must change angles to ones that are between 0 and 90 on every single piece of it in order to get credit. We only know how to do right triangle trig. We do not know how in this course to do the cosine of 215 degrees all by itself. We have to break it down with an acute angle. So now we need to enter these on the calculator. So first I'm going to do the ones with the cosines. My top row, the way that I wrote it, and I tried to save a little time and space since we're drawing 3 diagrams. That's why I'm letting you start the shortcuts now. 25 cosine 20 degrees minus 50 cosine 35 degrees. I need to put that into my calculator. So 25 cosine, so trig, go over to cosine and enter 20. Remember, whoops, read the 2. 20, I like that better. Remember to go out of the parentheses, and then it was minus 50 cosine 35 degrees. And enter. And that is my new I hat. So I am going to control and then the bar button so it stores it. I don't need that old I anymore. So I'm going to say my new I is, and now the calculator will replace the old I with negative 17.465, except the calculator will remember all of the extra digits. So I need to write that down, including that negative sign. So I get negative 17.465. Don't forget the I hat in there. Now I need to enter my 25 sine 20 degrees minus 50 sine 35 degrees. So 25 sine 20 degrees, get outside that parentheses, minus 50 and sine of 35 degrees, and enter. And this is my new j hat. It is also negative, so I want the calculator to remember that. So control and store it. And I don't need the j from the first problem anymore, so I can call this j, and it will replace the old j with my new j. And I need to write down negative 20.128 for my j hat. So then I had minus 20.128 j hat. That is where I end up. My question actually says how far from the cabin did we end up? So we're going to have another step here in a moment. First, let's draw our two vectors end to end and our final result and talk about where this means we ended up. So we started off with a little short vector into the first quadrant, like this. And then right where that one ended, we turn, and now we are going to go back this way, just a slightly steeper angle, but we're going to go twice as far back this way. Sorry, the calibration's off just a little bit. But we're going to end up in the third quadrant. That means my final vector is something like this. In the third quadrant. Third quadrant is always negative, negative. Notice that matches what I had right here, negative, negative. Sometimes when you draw these vectors end to end and you're just freehand drawing, it's hard to tell, am I barely on this side of the axis or did I barely cross into that other quadrant? This one is pretty clear, but you're going to have some where you can't tell just by doing the picture. So you must look at this answer and say, oh, I need to end up in quadrant 3. I need to make sure my picture shows that. Now what this question asks is, how long is that red arrow? I know the blue one was 25 and the green one was 50, but how long is the red one? Well, if I did my little right triangle here, this is my final I hat. This is that 17.465. This is my final j hat. Mine's not drawn really to scale, but that final j hat is negative 20.128. So if I think about that being a right triangle, I wouldn't really label it with the negatives on there when I measure distances, but now I have a right triangle, and as we all know, we can get the length of that hypotenuse with our Pythagorean theorem. So we know that r squared is going to be I hat squared plus j hat squared. Now, it's not okay to say 17.465 squared plus 20.128 squared and then take the square root of that, because we rounded those numbers when we wrote those two numbers down. So we can't reuse it to do any other calculations. What we can do, though, is to have our calculator use the stored values. So that means that r will be the square root of the I hat squared plus the j hat squared. So that's what I'm going to have the calculator do for me. So I need to do my square root sign. It's right beside the 4, except it's up above it. So control and then that x squared button to get a square root sign. Now this is why I stored that I hat and j hat. All I have to do now is to say I, and then I push my x squared button beside the 4, stay inside that square root and do plus, and then I ask it, remember the entire j, all of those numbers, not just the rounding, and square that, and then I push enter, and it tells me that I end up 26.649, whatever our distance is. Let me go back and look at that. So we end up at 26.649 miles from the cabin. by doing this calculation on our calculator. And that finishes our new material. So I will pause the video.